नमस्कार. यश अकॅडमीमध्ये आपलं मनपूर्वक स्वागत. Dear students, today we are going to discuss the very important topic, that is a shortcut for determining the isoelectronic and isostructural species. First of all, we'll discuss what is meant by the isoelectronic species. The species having the same number of electrons are called isoelectronic species. First of all, you write here species, then write group number, and then write the number of valence electrons. First example, XeF2. Group number is 18 and that of fluorine is 17. So from the group number we can calculate the number of electrons for xenon. As it belongs to group 18, there are 8 electrons and there are 2 F atoms. So 2 into 7. So 8 plus 14 is equal to 22 electrons. In second case, IF3. It belongs to group 17 and F also belongs to group 17. So number of valence electrons in I is equal to iodine is equal to 7. There are 3 F atoms, so 3 into 7. So 7 plus 21 is equal to 28 electrons. Now third case, BeCl2. The group number of beryllium is 2 and that of Cl is equal to 17. So here we can write the number of valence electrons 2 in case of beryllium, and in case of Cl there are 7 but there are 2 Cl atoms, so 2 into 7, so 2 plus 14 is equal to 16. In case of TeCl3 Te, it belongs to group 16 and Cl belongs to group 17. So in case of tellurium, there are 6 valence electrons, there are 2 Cl atoms, so 2 into 7 is equal to 6 plus 14, so is equal to 20. Now in last case, the I, it belongs to group number 17 and Br, it also belongs to group number 17, but here it carries one negative charge. So in case of iodine there are 7 electrons but there is a one negative charge, so one electron is accepted. So there are 2 Br, 2 into 7, so 8 plus 14 is equal to 22. So in this way we can calculate the number of electrons, and now in first case there are 22, in second 28 electrons, in third 16, in fourth case 20, and in last case, that is IBr2 minus 1, there are 20. So here we can say that XeF2 and IBr2 minus 1, these two species are isoelectronic. Now we will discuss the isostructural species. So what is meant by isostructural? Isos means same structure, means the species having different atoms or elements in them but they have the same hybridization, means type of hybridization is same and therefore they have the same structure or shape. So such species are called isostructural. त्यामुळं या आयसोस्ट्रक्चरल स्पेसिस शोधत असताना कशा पद्धतीनं त्याचा शोध घेतला पाहिजे, तर तुम्ही हायब्रिडायझेशन त्याचं काढायचं असेल तर तुम्हाला या गोष्टी माहीत असायला पाहिजेत. हायब्रिडायझेशन काढायचं आहे तर पहिल्यांदा फर्स्ट यू कॅल्क्युलेट द सम ऑफ अटॅच्ड ॲटम्स टू पर्टिक्युलर ॲटम ऑर दॅट ॲटम. म्हणजे फॉर एक्झाम्पल यू टेक मिथेन. In methane, carbon is a central atom and 4 hydrogen atoms are attached to it. So here you have to write the sum of atoms attached. The 4 H atoms are attached to carbon atom. Now you have to calculate the lone pair of that particular atom, that is carbon. Here carbon, it belongs to group 14. Okay, so there are 4 valence electrons, and so out of 4 valence electrons, the 4 electrons are used in the bond formation. So subtract 4, so 0. So there is no lone pair of electron. So total is equal to how much? 4. And 4 corresponds to sp3. So means if the sum of attached atoms plus lone pair is equal to, if it comes 4, then the type of hybridization is a sp3. Okay, now consider the second case. In second case is a water, and here central atom is oxygen and it belongs to group 16. And in water molecule, the 2 hydrogen atoms are attached. Okay, then you have to calculate the number of lone pairs. Here how many electrons are valence electrons? In case of oxygen, 6 electrons. So 6 valence electrons in case of oxygen, and out of 6 electrons, 2 are used in the bond formation with hydrogen. Now subtract 2, so 4. 4 electrons means there are 2 lone pairs. So total is 4. So this total comes 4. So the type of hybridization is a sp3. Okay, in third case, here 4 atoms, F atoms are attached to xenon, and xenon, it belongs to group 18. So there are 8 valence electrons in case of xenon, correct? So out of 8 electrons, 4 electrons are used. So subtract 4. So what is left? Only 2. 2 electrons means 1 lone pair. 1 lone pair. So is equal to, so the hybridization is sp3d1. Now the next, fourth example, XeO2F2. Here you write the number of atoms attached to central atom, that is xenon. So in all there are 4. Okay, now this xenon, it belongs to group 18. While solving such type of examples, you should know the whole periodic table and the position of each element with atomic number as well as group number. So there are 4 atoms are attached. Xenon, as it belongs to group 18, there are 8 valence electrons. Now here out of 8 electrons, 2 electrons are used. 2 electrons are used with bond formation with fluorine. So 6 are left. But here the xenon it forms double bond with oxygen, and there are two oxygen atoms, so it forms two ZeO double bond. म्हणजे दोन हे आपल्याला पाहायला मिळतील. Means it uses 1 2 3 4 electrons for bonding with oxygen. So total left is a 2. So 2 electrons means there is a one lone pair. So is equal to 4 plus 5 is equal to sp3d 1 plus 3 4 plus 1 5. Next IF3. There are 3 fluorine atoms attached to iodine. Group number of iodine is 17. So 7 valence electrons in case of I. Out of 7 electrons, 3 electrons used with bond formation with fluorine. So how many electrons are left? 4 electrons, means 2 lone pairs. So total is equal to 5. So type of hybridization is sp3d. हे यासाठी असेल, हे यासाठी. नेक्स्ट वन, beryllium, it belongs to group 2 and 2 Cl atoms are attached. So 2 plus 2 valence electrons in beryllium. Out of 2 electrons are used in the bond formation. So 0 electrons are left. So there is a no lone pair of electrons. So total is a 2. So hybridization is a sp. So 2, if there are 2, then sp hybridization. If there are 3, sp2 hybridization. If there are 4, sp3 hybridization. And if there are 5, then type of hybridization is sp3d. बरोबर आहे. म्हणजे हे या पद्धतीने आपल्याला सांगता येईल. नाउ नेक्स्ट एक्झाम्पल इज H3O plus. In H3O plus there are 3 hydrogen atoms are attached. Oxygen, it belongs to group 16. So there are 6 valence electrons in case of oxygen, and out of 6 electrons, the 3 electrons are used in bond formation with hydrogen. So 3 correct. But here oxygen acquires 1 positive charge, means 1 electron is lost. So total 2, 1 lone pair. So is equal to 4. So the type of hybridization is in H3O plus is a sp3. Now in SO4 2 minus there are 4 oxygen atoms plus you have to calculate the lone pair of electrons on sulfur atom. As sulfur it belongs to group 16. So there are 6 electrons. There is 2 minus negative charge, means you add plus 2 electrons. So total is 8 electrons, and out of 8 electrons, here sulfur it forms double bond with oxygen. So in all there are 4 oxygen atoms. Okay, आता हे 4 ऑक्सिजन ॲटम जे असणार आहे ते 4, याचा अर्थ सल्फर इट युजेस 8 इलेक्ट्रॉन्स. So 0 lone pair. So is equal to 4 is equal to sp3 hybridization. So in this way we can calculate the इलेक्ट्रॉनिक ॲज वेल ॲज आयसोस्ट्रक्चरल स्पेसिस. म्हणजे कोणत्याही परीक्षेला यावर प्रश्न विचारला तर या पद्धतीनं तुम्हाला ते सोडवता येणं अपेक्षित असणार आहे. धन्यवाद.